So I'll give you the stage, and anytime you want to get back into it, please feel free.
Yep. All right. Thanks. All right. Let's get into it. So we're just going to do some quick coverage of containers, and that's like arrays, maps, sets, that sort of thing. So just to kind of contrast it with like C#, because these are like, pretty typical container APIs that you'll want to be using. So for a dynamically sized list, so this would be the equivalent of list in C#, it's just TArray. The generics work pretty much the same. So if you want an array of strings, you can just make an array of strings like that. Very straightforward. For maps, which are dictionaries, so it's tmap. So keyed on strings, and then in this case we're gonna have strings as values because I don't have another type handy. Maps of strings if you want, right? And then the last one is a set, which is basically it's the same thing as a list, except it's making sure that that there are no duplicates in there. It's just everything. There's only one copy of everything at most, and so we just create a set of strings. Important to note is that these types also work for the UObject garbage collection that we're going to talk about soon. So if you want to keep track of, say, an array of actors, this works with the garbage collector, right? Because the garbage collector is aware of arrays, it's aware of maps, it's aware of sets, as long as you declare the hue property on them. We'll get into hue properties later, but I just did want to say that the containers do work with the garbage collector for just doing the garbage collected pointer stuff. You typically, so there are arrays in C++, like raw arrays in C++. So you can make a char 250, I think it's char buffer 256, right? So you will remember earlier we would have been talking about things on the stack. This declaration here is going to actually it's actually going to reserve 256 bytes on the stack. This is not heap allocated array memory or anything like that. When this function runs, it will move the stack pointer up by at least 256 bytes to make room for this buffer. And then, you can modify it and use it as like temporary storage and kind of do whatever you want. Typically, you're not really going to use these too much in like your Unreal Engine code. Again, it's really kind of, do you want a raw buffer of characters? Well, maybe in the rare occasion when you do, again, it's usually like network buffers or serialization buffers or something like that. But you're not really going to use them because they are fixed size. They're a fixed size on the stack, or they're a fixed size in the heap. It's just a fixed size of memory. Not really useful for like dynamic lists. So you typically will use like TArray instead, and all of the proper typing that comes with that. If we have a TArray, let's say we have a TArray of, I'm going to use fstring as an example, right? And let's just go and add some strings. Hello. 1, 2, 3. All right, cool. Now we want to iterate over this array in C++. You can, of course, do the kind of classic conventional way, which is like, a.num, and then you can, and then you can access it via, a.i to kind of do your numeric iteration. You can also use iterator-based iteration, and you initially might do like, you might think, okay, I'm just going to iterate through this array. That's fine. But what this is actually doing, is really important to note, is that this is actually doing a copy every single time you iterate through this array, because it is making a copy of the string from the array as we iterate through it. We don't want to do that. And also this is true in the numeric example. If I do, come on, go back. Yeah. If I do, if I do this, this is also making a copy of the string in the array every time we iterate, and we don't want to do that. So what we're going to do is we're going to take advantage of our const reference stuff that we learned earlier, and we're going to make a const reference to the array. And now we don't have any copy happening, right? We're just iterating through the array elements. We're just getting the reference, which underlyingly is just the memory address of the thing that's already in the array. And now we have zero copy iteration. So whenever you're iterating through arrays, through maps, what have you, you really want to be using this const ref. Otherwise, you're going to be doing unnecessary copies. And you don't want to do that because it's just a waste of cycles. The iteration stuff, you will also have seen me in a few places. I will have used auto, which auto means automatic type, right? The C++ compiler will figure out the type for you. And it's really useful when like the type is going to expand out to something that's ridiculously long. But it is important to note that auto will not, do your const ref for you. So if you do this, for example, that is a copy on every iteration. You have to do const auto ref to get your just reference, just iterate through with references. You probably typically see this, or you probably will typically do this when you're like iterating through like a map, right? And you don't want to be like, okay, it's T key value pair F string, it's kind of redundant. You're iterating through a map, just do auto, and should be right. Yeah, that was a really short one. That's all I had on arrays. 7 minutes, so pretty much in like the 10-minute window I'd allocated. I did have a thing on like if we have time, we can build our. Yes, someone in the chat asked. So auto infers the type like var in C#. Basically, yeah, it does. It's just that you have to keep in mind that in C++, because usage defines the memory semantics, not the type. In C++, we also have to apply, the reference const reference onto auto if we want by reference semantics. All right, well, since we're supposed to be in the uObjects and garbage collection section anyway, according to schedule, I'm just going to jump straight into that.